Laminated Wood Systems has been the industry leader in designing and supplying ELAM, engineered laminated wood transmission and distribution structures, since 1992. LWS has supplied thousands of structures worldwide, designed for use in tangent, unguide, angle, switch, and substation applications. ELAM structures are an economical, environmentally sustainable alternative to other engineering structures such as steel, composite, or concrete. Glulam technology has been in use for structural members since the late 1800s. The first glued laminated wood utility structures are still in service today and were installed in 1963, predating the first steel utility poles. In this short video, you will see the complete Glulam manufacturing process of ELAM laminated wood T&D structures, as well as the quality control procedures that are in place to ensure a consistent manufacturing process that complies with stringent industry standards. ELAM structures are made from an abundant, renewable, managed growth timber resource. The most common timber species used to manufacture ELAM structures is either southern yellow pine or coastal Douglas fir. The process begins by grading the lumber. The lumber is most often graded visually, but can also be graded mechanically using a continuous stress rating machine. The stress rating machine applies a non-destructive bending load to each board to obtain a stress rating. Proprietary layup specifications, unique to LWS, incorporate high and medium-grade lumber in the manufacturing of ELAM structures. ELAM poles are comprised of very long pieces of lumber. For example, a 90-foot pole is made using 90-foot long pieces of lumber. This is achieved by gluing shorter lengths of lumber together using a process called finger joining. The finger joining machine cuts a series of V-shaped grooves into the ends of each board. Glue is then applied to the finger joint and the boards are joined together end to end, ultimately becoming one long single piece of lumber. Rollers maintain pressure to the finger joints as the boards pass through a microwave tunnel, which rapidly cures the glue. Inline stress rollers apply a non-destructive load to each finger joint to test its strength. If any joints are found to be weak, the joint is rejected. A patented groove known as pentatrate is cut into the inner edges of the boards, which will allow the preservative treatment to penetrate the full length of the pole during pressure treating. This feature also provides for drainage should any moisture enter the unglued edge joints. As the jointed boards exit the microwave tunnel, a flying cutoff saw cuts the boards to length according to the size of the pole being manufactured. The boards are then grouped into stacks. Each one of these stacks will become an ELAM structure. The grouped stacks are now ready to be sent to the glue line. Each board passes under the glue applicator and then is stacked vertically in the gluing rack. As the clamps are positioned in the rack, a worker pounds down the edges of the boards to minimize the gap in the unglued edge joint. This unglued edge joint that is allowed by ANSI standards varies according to the size of the pole and can be as wide as 13/16 of an inch at the time of manufacture. The glued boards are clamped and allowed to cure for approximately 8 hours. All fabrication processes comply with ANSI standards, as well as the AITC or APA Engineered Wood Association standards. Quality control records are maintained by the laminating plant at all times, and samples from every gluing batch are tested daily for strength and glue performance. After curing, the clamps are removed and the pole is ready for finishing. The first step in the finishing process is planing. The pole passes through the planer where the top, bottom, and uncut side surfaces are planed smooth. Most ELAM poles have a continuous width below the ground line and will taper from the ground line to the top. A bandsaw is used to trim off the stair step side of the pole. This is referred to as the cut side of the pole. ELAM structures include foundation design and are shipped as a complete kit that includes all mounting hardware and foundation systems. Since each pole is pre-drilled to accommodate the attachments, it is required that all holes be accurately drilled according to LWS's specifications. A two-step quality assurance process requires that one worker measure and lay out the hole locations and sizes. while a second worker double-checks the accuracy prior to drilling. Once the hole size and locations have been verified and checked, the holes are drilled using specialized drilling equipment. Drilling the holes prior to pressure treating ensures complete penetration of the preservative in and around the holes. Having the poles arrive at the job site pre-drilled enables crews to quickly and efficiently attach the hardware, foundation angles, and insulators. Longer ELAM poles are sometimes manufactured in two sections, spliced together with steel splice plates. The splice plates themselves are used as the drilling guide to ensure accurate assembly in the field. The corners of the pole are rounded using a router to ease the edges. To ensure maximum preservative treatment at the ground line, a second series of small holes are drilled 2 feet above and 3 feet below the ground line. Once all the finishing work is complete, the balance point is determined and marked, as well as the estimated treated weight. Pole identification tags are then attached 48 inches above the ground line and also on the pole butt. The identification tag contains the height and class of the pole, customer information, manufacturing date, and location. The poles are now ready to be transported to the treating facility. ELAM engineered structures are most often treated with penta and oil. However, they can also be made from pre-treated lumber if necessary. All ELAM poles are treated in accordance with American Wood Preservers Association specifications. Laminated Wood Systems' extensive manufacturing network allows for consistent delivery times on most any size order of 6 to 8 weeks after drawing approval. With multiple manufacturing and treating facilities located throughout the U.S. and Canada, LWS can minimize shipping costs by manufacturing the structures near the project location. Laminated Wood Systems is proud to be the leader in supplying engineered laminated wood T&D structures to the electric utility industry since 1992. The LWS sales and engineering staff have an unmatched reputation for the most experienced, highest degree of technical knowledge, and customer support in the industry. For more information on ELAM structures and all of Laminated Wood Systems products, call 800-949-3526 or visit www.lwsinc.com today.